All right, and we are officially live. So, good morning, good afternoon, good evening to our viewers around the world. We're so excited to be back in the new year for our first ever live stream of 2023. But guess what else is new? It's my pleasure to introduce Joshua Jebaraj on his maiden live stream with AppSecEngineer. Joshua is our cloud and cloud native security lead, and he also specializes in container security. In fact, Joshua was the lead trainer on our brand new learning path for Google Cloud Security, which we just released a week ago. For this live session, however, he's going to take us on a hands on walkthrough of containers and how security works on a containerized application. But that's enough from me. Take it away, Joshua.
Thank you, Anish. Thank you for your wonderful introduction. I'll start by sharing my screen. I hope my screen is visible.
Yep.
So, thank you, Anish. Thank you for your wonderful introduction. Hello, folks. Welcome to my talk on understanding the container internals. Before going to the actual talk, a small introduction about me. My name is Joshua Jebaraj. I work as a security researcher in V45. My primary in V45, I primarily work on cloud and cloud native technologies. I regularly share my learnings via blogs and projects at my website. I'm pretty much active on my social media. This is my Twitter handle. Feel free to reach out in case you want to relate anything related to security or tech in general. The learning objective of today's session is going to be we are going to go deep dive into the container and see how it works internally and how the container technology help you to provide the security isolation. And this talk is going to be most of the section of the talk is going to be hands-on. So as a speaker ritual, I'm praying to the demo god so all the demos work perfectly. And if you folks have any questions during my live session, feel free to ask in comments. I will try to answer most of the questions as much as possible. Before going to the actual talk, let's start our session with a small story. Once there was a boy who who had a dog name called Max and cat name called Cooper. Max and Cooper kept on fighting among themselves. In order to prevent the fight, the boy built a wall between the Max and Cooper. After some time, another problem arises. Max started to stealing the foods of Cooper. This leads to Cooper to starve. In order to solve this problem, the boy started to serve the food in different plate for Max and different plate for Cooper. With that story, with that, we are coming to the end of the story. But folks, don't forget the story. We will be coming back to the story and try to see how the story relates to container. So the first concept that we are going to see is namespace. Namespace is a Linux feature that provides an isolation environment. Going back to our story, you can think it of namespace as the wall that built between the Max and Cooper. Similar to the wall in Linux, namespace provides the isolation. In modern Linux, there are many namespaces out there, but for our today's session, we are going to particularly focusing on 6 namespace which provides a container isolation. We are going to explore the UTS namespace, we are going to explore IPC namespace, user namespace, process namespace, network namespace, and mount namespace. Before going to the namespace in deep dive, let's try to some of the important system call that helps us to provide and create the namespace. The first system called is fork system call. Fork system call is used to create a child process. And the second system call is a clone system call. Clone system call is similar to a fork system call. The main difference between the fork and clone is in the clone system call, we can specify on which namespace the child process has to be created. The third system call is unsearch system call. Unsearch system call is used to move the current process into a new namespace. And the fourth and the last system call is set and system call. Set and system call is a Linux system call that used to move any existing process into a new namespace. The main difference between the unshare and setns command is in unshare command, only the current calling process is moved into a new namespace, whereas in the setns command, we can move any process into a new namespace. The first namespace that we are going to see is UTS namespace. UTS namespace is a Linux feature that provides the isolation of host name and domain name system. Let's see how we can create a UTS namespace with the Linux tools. In order to create a namespace, I'm going to use a Linux command called unshare command. So I'm going to create the new namespace using unshare command. So once it is done, you can see there is nothing much changed. But if I change the host name in the new namespace, let's say I change the host name to demo. If I execute the host name command, you can see the host name is changed. Whereas if I execute the same command on the root namespace, you can see the change that I made in the child namespace is not reflected. Let's see what happens if I come out of the namespace and try to execute the host name command. So I'm coming out of the namespace using exit command. Once it is done, I'm trying to again see the host name. So you could see the changes that we have made in the new namespace is not being reflected. So this is how we can use the unshare command to create a new UTS namespace. We have seen the demo. The next namespace that we are going to see is IPC namespace. IPC stands for Inter-Process Communication. Using IPC namespace, we can isolate the inter-process resources like message queues, semaphores, and shared memories. Let's see how we can create a new IPC namespace using the Linux command. In order to show the IPC, how the IPC namespace is created, I'm going to write a simple program. So in order to save the time, I already wrote the program. I'm just going to copy and paste this program, and I'll quickly walk through this program. So this is a simple C program. It's what it's going to essentially going to do is like in the first step, it's going to create a shared memory. Next, it's going to read the user input and it's going to store in the shared memory. So in order to compile this program, what I'm going to do is like I'm going to use the GCC compiler and compile the program. Once it is done, I'm going to run the compiled program. So it's created a shared memory and asking the user input to write. So for this, I'm going to write it as a demo. Once it is done, we have successfully written the demo data into the shared memory. Let's write another program in order to read the data from the shared memory. So I am copy pasting. I'm simply creating the new program. So this program what going to do is like it's going to read a data from the shared memory and print it in the terminal. Again, in order to compile this program, I'm going to use the same GCC compiler. This time I'm going to pass the receiver program. And on the output, I'm going to specify something like received. So it doesn't matter. Like if I run the received compiled program, you could see I'm successfully able to read the data from the shared memory. Let's see whether I can do it in the newly created IPC namespace. So in order to create a new IPC namespace, I'm going to use the similar command and share IPC Once it is done, I'm going to run the same program. We could see we are getting the segmentation fault. This is because in the new shared name, in the new IPC namespace, new IPC processes get created. In this namespace, we cannot access the IPC resources that is present in the root namespace. If I execute out of the IPC namespace and if I run the same command again, you can see in the root namespace I'm able to read the shared memory data. So this is how we can create a IPC namespace using the unshare command. The next namespace that we are going to see is process namespace. Process namespace is a Linux feature that provides the isolation of process tree. This is very important in a security point of view because we don't want one container to see the process of another container, and we also don't want to see the container to see the process of the host machine. In order to create a process namespace, I'm going to use the unshare command and I'm going to specify the -p flag. So -p flag denotes a process namespace, and I'm going to add a additional flag fork. So using fork, in the new namespace, the unshare process is created, and I'm going to pass the shell command. So once it is done, I'm going to see all the process running inside the new namespace using PSFA. You could see the process present in the new namespace. Let's see whether I can able to access the process in the host or not. Sleep 100. I'm going to run a sleep command on my host machine. So if I do PSFA, you could see I'm able to see the process in the running the host machine. But this is not what happened when you create the container. Let's see if this is the same case in the container too. For the simplicity of the demo, I'm going to run a simple and I'm going to get the shell inside the container. So if I do PSFA, you could see I could not able to see the process running in the host machine, whereas in the process namespace, I could able to see the process running in the host machine. The reason the PS able to see the process running in the host machine because of the special file called proc file. So whenever we are calling the PS command, it's going to look at the special file proc file where it has details about all the process running in the system. In order to solve this problem, we can simply run an unshare command with the additional flag. So this time I'm going to run an unshare command with the additional flag mount proc. So this command what going to do is like it's going to create an own copy of the proc file system where it has only details about the child namespace process. So if I do PSFA again, we could see this time it could be only the PS command is looking on the copy of the proc file system. This time it displaying only the process present in the child namespace. So this is how we can achieve the process isolation using the process namespace. We have seen the demo how the process namespace work. The next namespace that we are going to see is mount namespace. Mount namespace is a Linux feature that provides an isolation of mount point and the file system to the each namespace. Let's see how we can create a mount namespace. So similar to every other namespace, I'm going to use an unshare command and I'm going to use pass and mount flag. So once it is done, I'm going to see all the mount points present in the file namespace using find mount command. So it's displaying all the mount points present in the child namespace. I'll split the terminal. Now in this terminal, the shell is running on the root namespace. Let's see what happens if I execute the find mount command in the root namespace. Oh, you could see both of the input are 90% similar. This is because due to something called subtrees. Let's talk about what is subtrees. Subtrees is a Linux mechanism through which mount points is propagated from one namespace to the another namespace. Currently, Linux support 4 type of subtrees. The first one is MS shared subtree. In the subtree, the mount points is shared between the namespaces. Let's say if I create two namespaces, namespace 1 and namespace 2, if I create namespace, any mount point in the namespace 1, then in the namespace 2 also we can see. Again, on the opposite, if I create any mount point in the namespace 2, it is reflected on mount namespace 1. The second type of subtrees is ms underscore slave. In this subtree, the mount points propagated in the only one direction. Let's say we have one parent namespace and child namespace. If we create any namespace in the any mount point in the parent namespace, it gets reflected in the child namespace. Whereas if I create any mount point in the child namespace, it's not being reflected on the parent namespace. And the third subtree type is ms underscore private. If you specify the ms underscore private as the subtrees, then the mount point doesn't propagate into the namespace. And the last type of subtree is ms underscore unbindable. This type of subtrees is, if we create any mount point with ms underscore unbindable, we cannot create a mount point. The reason that we are seeing the mount point from the present in the root directory into the child directory, because by default unshare command takes a ms underscore slave subtree. So that's why I'm able to see the mount point present in the host namespace into the child namespace. This also created another problem. So if I do ls, I could able to access all the files present in the host system. Let's see whether it is the same case in the container. Similar to this, I am going to run a Docker container. If I do ls, I could able to see only the file system present in the container. I could not able to access the file system present in the host. In order to solve this problem, we are going to use a Linux tool called pivot root. So the pivot root is the Linux tool. Using the pivot root, we can change the root mount point. So let's see how we can create a file system isolation with the pivot root. The first thing I'm going to download is the Alpine image tar file. So once it is done, I'm going to create a new directory called rootfs. So this directory is going to, the directory that I have created is going to be act as my root directory in the new namespace. Once it is done, I'm going to unzip all the files that I have downloaded into the my rootfs file. So if I do ls in my rootfs, we could see I'm able to see the similar file structure present inside the Alpine container. So once it is done, what I'm going to do is like, I'm going to create a new folder called old rootfs inside the my rootfs folder. So this is the folder where I'm going to put all my host file systems. Once it is done, I'm going to make my rootfs file into a bind mount point. In order to do this one, I am going to execute the mount -bind command, and I am going to tell create the directory as make the directory as mount bind point. Some people may ask like, why should I make it as mount point bind mount point? So if we go into the man page of the pivot root, it could say the following restrictions should apply, like the new root that we are going to mount should be a mount point. So that's the reason why I mounted as I created the bind mount. Once it is done, I'm going to navigate into the directory where the root file system. Now I'm going to execute the pivot root command. So what I'm telling the pivot root is, hey pivot root, make my current directory as my root directory and put all the previous root directory into a old rootfs file. So once it is done, if I have to export the path since the binaries are present in different directory. Once it is done, I'm going to unmount the old rootfs folder. Once it is done, if I do ls, we could see I'm able to see only the process present in my rootfs folder. So if I do cd double dot and if I do ls also, you could see I'm able to only see the folder present in my rootfs folder. So this is how you can combine the pivot root and mount unshare mount command to create a isolated mount points and isolated file system. So the next namespace that we are going to see is network namespace. Network namespace is a Linux feature that provides an isolation of network related resources. So each network namespace has a different set of network devices and different set of routing table and different set of IP tables. Let's see how we can create a network namespace in a demo. So in order to do this one, I am using a virtual machine. So this is my simple virtual machine. If I do cat etc shoe, it's running at Debian 11. In the first step, what I'm going to do is I'm going to create a two namespace. Unless previous namespaces, I'm going to use a special tool called IPNetNS. So using this tool, I'm going to create a new two namespaces. So I have created. So okay, I have to run it as root sudo su. So I have created a namespace 1 and I have created namespace 2. Once it is done, what I'm going to do is I'm going to use IPNetNS command and try to list. You could see I am successfully able to create two namespace. The next step, what I'm going to do is I'm going to create a virtual Ethernet cable. Virtual Ethernet cable is similar to the physical Ethernet cable that we have in our home. Using this virtual Ethernet cable, we are going to connect the two namespaces that we have created. So I'm going to create this virtual Ethernet cable. So I'm going to name it this end as VETH-NS1 and I'm going to name it this end as NS1 bridge. In the second step, I'm going to IP link add VETH-NS2. I'm going to name this end as VETH-NS2 and I'm going to name this end as NS2 bridge. Once it is done, if I do IP link list, you can see we have successfully created the virtual Ethernet cable. We have seen VETH-NS1 and VETH-NS2 and NS2 bridge and NS1 bridge. We have successfully created the virtual Ethernet cable. The next step, what I'm going to do is I'm going to take one end of the Ethernet cable and plug it in each namespace. So I'm going to execute this command. So the IP link set, and I'm going to tell, hey, take one end of the virtual Ethernet cable and plug it in namespace 1. And I'm going to do the same for the other namespace. I'm going to take one end of the virtual Ethernet cable and plug it in another this namespace 2. So if I execute the IP link list command, we could see 4 and 6 are now gone. Like this is because like right now these these two ends are only in the this namespace. I'll quickly reconnect. Sorry for the trouble. Meanwhile, folks, if you have any questions, I'm happy to take. Sorry, folks, for the issue. So right now I have created IP link list. I have created the virtual Ethernet cable. You could see these two ends are now gone in the root namespace. Now, if I try to execute into the namespace 1 and try to list out all the devices present here, you could see the virtual be it ns1 is present in the namespace 1. And if I execute the another command in the namespace 2, same command in the namespace 2, you can see this end is now present in the namespace 2. In the next step, what I'm going to do is like I'm going to assign an IP address of 10.0.0.1 to the one end and 10.0.0.2 to the other end. So I assigned this IP to this end and I'm going to do the same on the other end. So once it is done, by default, the devices that I have added is in down state. If you see here, it's in down state. So what I'm going to do is like I'm going to bring up the device. So I'm going to run this command. So this command, what essentially going to do is like it's going into the namespace 1 and bringing up the device. Similar to this, I'm going to execute into this namespace and I'm bringing up the device. Once it is done, the next step what I'm going to do is like I'm going to create a bridge interface. As the name indicates, bridge is used to connect the two things. In our case, I'm going to connect the namespace 1 and namespace 2. So I'm going to create a new device called bridge. I'll just copy and paste it. So once it is done, I'm going to bring up the bridge device. So once so far I have created the bridge device and bring this up. The next step what I'm going to do is like I'm going to connect these two ends into the bridge. So once it is done, so I have connected these two ends. The next step what I'm going to do is like I'm going to bring these two ends up. So if I execute the bridge link show bridge 1 command, we could see I'm successfully connected these two ends into the bridge. Finally, I'm going to add an IP address of 10.10.0 10.3 into the bridge interface. So once it is done, now I'm successfully able, now I can able to talk from namespace 2 into namespace 1 using this bridge. Let's see whether it is possible or not. So I'm executing into the namespace 2 and I'm trying to ping the device present in namespace 1. You could see one packet is received, one packet is transmitted and one packet is received and 0% loss. This tells I'm able to talk from namespace 2 to the device present in namespace 1. Let's see whether the opposite is possible or not. So this time I'm going to ping from namespace 1 to the device present in namespace 2. So here you could also see the one packet is transmitted and one packet is received. So this is how we are able to connect the two namespace using the bridge router. So in this section, we saw how to create a namespace using the ipnetns command, and we saw how to connect the two namespace using the bridge and adding the Ethernet cable like that. With that, we are going to move into the next section. The next namespace that we are going to see is user namespace. User namespace is a Linux feature that provides an isolation for user ID and process ID. This is very important in a security point of view because this allows the user to be root user in one namespace, whereas the same user will be non-root in the other namespace. This is typically seen in the container where the user will be a root inside the container, and outside of the container they will be the non-root user. So let's try to understand how this is important for security, because let's say a attacker get an shell access inside the container. Due to some misconfiguration, they break out of the container and get the shell inside the host machine. If they used the user namespace, even though they got the access root shell access inside the container, they will be still a non-root user inside in the host machine. Let's see how we can create a user namespace. And to be seen, like the user namespace is which is released in later part of the Linux, so it has more advantage, more advanced feature. One advanced feature is like for all other unshare command. Let's say I'm trying to create a IPC namespace. You can see I'm not able to create a IPC namespace. But if I try to create an IPC user namespace as a non-root user, I am able to create a user namespace even as a non-root user. So this is very advanced feature, and this is very useful in a security point of view. So I have created the user namespace, and you could see I am getting the shell as nobody. This is because the user inside the namespace is not mapped into the root namespace. In order to perform the mapping, I am going to run an unshare command with the additional flag. Here I am specifying, hey, create a user namespace and map the user that I have created into the root namespace. So if I do unshare R command, you can see I am currently in the new namespace. I am currently running as root. If I do ID, you could see I am running as root in the new namespace. Let's see, look at how the user is in the host namespace. In order to look at this one, there is a special file called uid map. So this command exactly what is telling this file, what is telling is like the user 0 is mapped to the user 1000 in the root namespace. So let's see, verify whether it is true or not. I'm going to create a file called root file, and I'm going to exit out of the user namespace that I've created. Once it is done, if I do ls la on the root file, it's saying that root file is created by the user Joshua. If I do ID, we could see the user ID of the Joshua is 1000. So if you remember previously, this ID is mapped to the root user inside the container, even though inside the user namespace. Even though inside the user namespace the file is created as a root user, but in the host file system it is only considered as created by the non-root user. So this is how we can create a user namespace using the unshare command. With that, we came to end of the namespace command. Next thing we are going to see is control group, C groups. So C group stands for control group. It is a Linux feature that allows you to allocate the resources like CPUs and memories and network bandwidth to the process. If going back to our story that we have seen for the dog and cat story, similar to giving food in separate plate, in the C group we can limit how much resource that each process can consume. By default, there is no restriction present in the Linux. Let's say if you have a 2 GB machine, 2 GB RAM machine, if you run the process that takes the whole 2 GB, then the Linux will simply run the program without any restriction. This is very dangerous in a security point of view, because let's say somehow the attacker got the access to create a process. In this case, the attacker could simply create a malicious process which takes the whole memory and CPUs, which leads to DDoS attack. And in C group, each process each subsystem is referred as controller. For example, you can memory is referred as controller, CPU is referred as controller, even memory bandwidth is referred as controller. As the time of I'm speaking, there are two versions of C group. There is a version 1 and there is a version 2. In the recent Linux distribution, version 2 is used. Even though version 2 is used released quite a time back, still most of the machines are still running on the version 1. So enough of the C group talk. Let's see the C group in action. So I'm exceeding out of the containers, out of the namespace. So we can see all of the controllers that is present in the host using the all the C groups that is present in the host reside under the sysfs C group folder. If I do this one, you could see there is a controller for CPU, there is a controller for memory, there is a controller for network bandwidth, everything. In order to demonstrate the program, I'm going to create a simple bash program. So I have created a test.sh. This is a simple bash program which prints hello, welcome to AppSecEngineer to the terminal, and sleep for 5 seconds and again printing. So I put it inside the while loop, so it's run forever. So the idea of so in the C group demo, what I'm going to do is I'm going to restrict the access to the terminal for the program using the C groups. In order to create a C group, creating a C group is very simple. Like we have to go into the controller folder. So in our case, I'm interested in device controller. Once it is done, I'm going to create a new folder called C group test, and I'm navigating into the C group test folder. Once it is done, if I do ls, you could see there are files that is pre-populated by the system. So the two files that we are interested in, device.deny and task file. In device.deny file, we are going to put the list of devices that we want to deny, and in the task file, what we are going to do is like we are going to put the process ID which we want to put it in the new namespace. So in this example, I'm going to deny this device. So I'm going to echo this content into the device.deny. So say I'll quickly walk through what it exactly is going to do. So the C parameter stands for character, 5 stands for major number, and 0 stands for minor number. Since we are blocking the write access, so I'm putting it W. You could we can easily find the first 3 parameters if I do ls pt sorry ls la py You could see there's a character bit, and this is a major number, and this is a binary number. So right now we have put the device that we want to deny. The next step, what I'm going to do is like I'm going to split the terminal, and I'm going to run the test process. So it's showing permission denied. I am giving the executing permission using chmod command. So once it is done, if I do test.sh, you could see it's currently printing the welcome to AppSecEngineer. In in order to put the process inside the new C group, what I'm going to do is like I'm going to execute this command. So it's showing some error. Echo. I'll quickly see what's error. Like echo area of test.sh. It's not area of test.sh. Yeah. So it's somehow not working. I'm going to manually get the process ID. Okay, maybe in I'll open the new terminal. Split terminal. To CSFA. Why I'm not seeing the process? I do start a search and with the terminal. I do yes. CSFA. Okay, I'm guessing this is the process ID. Let's see whether it works or not. So I'm going to navigate into the C group test file that I've created. Once it is done, I'm going to echo this process into this ask file. You could see once I have put the this test.sh file, now I am getting the permission denied error. So this is how you can create a C group to restrict the access to the resources. But the demo that I have shown is how we can create it manually. But creating manually is not feasible because like we have to create a folder and we have to put the process ID into the new namespace. In order to ease out the process, there is some of the Linux C group tool. Let's install the Linux C group tools in the machine. So once it is done, I'm going to create a new C group called memory. So new C group called foo under the resource memory. Once it is done, what I'm going to do is like I'm going to give like only 500 bytes memory for this C group. So if the process takes more than 500 bytes, it's going to kill. Let's see whether it is true or not. I'm going to run this command. You can see the process is get killed. Let's verify whether it is due to C group or not. If I do ts msc command, you could see the process is get killed due to out of memory. Let's give around like a 5 lakh byte. This time the process should successfully able to run. If I execute the same command again, you could see this time it's successfully running because this time it has enough resource. So this is how folks you can use the namespace and containers to create the isolation and prevent the resource and do the allocation using the C group. And these are the some of the references that I took while preparing for the session. And with that, we came to the end of the session. If you folks have any questions, I am happy to take.
All right, so I think we're at the end of the session, right?
Yeah, we are done.
Great. Um, thanks so much for this fantastic live code session, Joshua. That was a great way to kick off the new year, and I can't wait to see you again and at many more live streams in 2023. A huge thank you to our viewers who have joined us today. I really hope you've learned something new. You can check out all our hands-on container security courses on AppSecEngineer and try them today. You should also take a look at our brand new Google Cloud Security Learning Path we just launched last week. Anyway, that's all for now, and we're really looking forward to seeing you next month. See ya. Bye-bye.
See you folks. Bye.
Bye.